Multi-access edge computing deployments enable general cloud computing capabilities and services to be available at the edge of mobile networks, offering, amongst others, higher computing resources and storage capacity. These resources are fundamental for industrial 5G users and applications that require processing of their data. However, these industrial 5G users and applications usually generate very high volumes of data to be processed by edge nodes, and on top of that, they often require near real-time responses. It then becomes fundamental to investigate bandwidth and latency aspects in multi-access edge computing deployments for Industry 4.0 use cases. InterDigital Europe has partnered with Amazon and Vodafone UK to execute an Industry 4.0 use case demonstration that leverages on the latest Amazon technology for multi-access edge computing, the AWS Wavelength. Wavelength is a mobile edge computing infrastructure that can be deployed at the communication service provider premises, bringing edge nodes even closer to users and applications. We will be using a Wavelength deployment at Vodafone UK's premises, and we will be investigating bandwidth and latency aspects. Our industrial use case in this demonstration is the Zero Defect Manufacturing, or ZDM. The goal of the ZDM is to automate the control of a factory. The factory is monitored using a high-resolution camera. The video captured by the camera is streamed to an edge, where multi-access edge computing capabilities process the video stream and provide decision-making for the automated control of that factory. Our ZDM use case is a two-part setup. At the factory, there is a robotic arm mounted on a sliding rail, the objects or goods being manufactured, a conveyor belt, a disposal bin, an HD camera, and a fog computing node that gives commands to the factory equipment. There is also an additional laptop used to remotely connect to the Wavelength computing resources. In this demonstration, the Wavelength computing resources are the edge node, and they are co-located with Vodafone UK's core network. A laptop is used in this experiment next to the ZDM setup for remote desktop connection access to Wavelength computing resources. The camera is capturing a high-resolution video and is streaming it to the Wavelength using Vodafone UK's 5G network, using a CPE as a gateway. At the factory, the robot arm picks up products and places them on a running conveyor belt. In this demo, we use cubes as the main product of the factory. We have trained our AI system to detect cubes having black circular marks as defective objects. The edge node, or the Wavelength component, has a trained YOLO engine capable of detecting objects and categorizing them as defective or non-defective. The video is transmitted towards the Wavelength, where the computing resources run the YOLO engine and categorize the objects. In this scene, we can see the robot arm placing a monocolored cube in the conveyor belt, and we see the Wavelength detecting it as a non-defective object. In this scene, however, the robot arm places a cube with black circular marks in the conveyor belt. We can see the Wavelength component running our trained object detection engine and identifying this cube as a defective object. Here we can see a screen capture of the laptop that remotely connects to Wavelength. In there, we can see the video captured from the factory and streamed into Wavelength, where the trained YOLO engine is detecting a defective object. After categorizing the objects seen in the video stream at the Wavelength, a Python script sends instructions back to the fog node that controls the factory, instructing it to either dispose defective objects to the disposal bin or to allow them to continue to roll out of the factory. In these scenes, we can see the full setup and demonstration running, with the objects being placed in the conveyor belt, the video being streamed towards the Wavelength, using the Vodafone UK's 5G network, the categorization of the objects, and the automated control of the factory in our ZDM use case.